Welcome back, boys and girls. So, solving by substitution is utilized when one variable is isolated. So in this case, y is isolated, so it's alone. So what we're going to do is replace or substitute y in the other equation. It's also called the replacement method. So I'm going to rewrite this expression here, only I'm leaving a space where I'm going to plug in the other expression. So I'm replacing y with 2x plus 1, and now I have one variable in the equation, so I can just solve it the way I normally would. So I'm going to distribute, combine like terms, move the 2 to the other side, and I get x equals 3/7. Now I need to remember to plug that 3/7 back into one of the equations to get the y value. So doing that gives me y equals 13/7. All right, our next example, same rules. Replace. So one of the y's, both of the y's are isolated, but we just replace one of them with the other expression, rewrite our equation, solve the way we normally would, and we get x equals -1. And now we get the other variable, the y in this case, by plugging in a -1, and that gives us y equals 5. Now, since I used the top equation to get the y value, I'm going to plug both values into the second equation to check my answer. If it works out, yes, your math teacher did it correctly. All right, if it's close to isolated, so if it doesn't take too much work, then we can isolate one variable and apply the same recipe. So in this case, I'm going to subtract 7x from both sides. Now I have an isolated y. I'm going to replace the y in the other equation with that expression. Now I distribute, combine like terms, move the 30 to the other side to solve, and that gives me 1. I guess that means we're almost at the bell, kids. So now I plug the 1 into one of the expressions, get y equals 3. Since I used the bottom expression, I'll plug the 1 and the 3 into the top expression to check my answer. See you next class.